In the previous video, we got to see how useful it is to have a vertex form. With a vertex form, you can easily determine the vertex, the axis of symmetry. We can easily solve for the x-intercepts and the y-intercept. But oftentimes, when we're not as lucky to have the vertex form given to us, sometimes we may have a standard form. So the question is, how do we convert the standard form of a quadratic function to a vertex form? So in this video, I'm going to introduce the first method, which is using completing the square. Now let's review perfect square trinomial formulas. There are two of them. The first one is a squared plus 2ab plus b squared. If a function can be written in the form, the first term is squared, second term is squared, and the middle term is twice the product of the two terms, then that means it is a perfect square trinomial, and therefore it can be written in the form a plus b squared. Similarly, if you have a squared minus 2ab plus b squared, then that can be written as a minus b squared. In example 2, we want to write these trinomials here as perfect squares if possible. So the first example is x squared plus 4x plus 4. First step you should do is determine if the first term is a perfect square, and it is because it's already written as a square form. The second step is to look at the last term to see if you can write that as something squared. 4 is a perfect squared. In fact, it can be written as 2 squared. Now, the middle term in the formula, we are supposed to use the first formula since both signs are plus signs. And in that formula, the middle term is 2ab. So according to this, I can tell that my a, my first term is x, and b, my second term is 2. So when we say 2ab, we're looking at plus 2 times x times 2. And then put in the plus sign. Now, just checking, 2 times x times 2 gives us exactly 4x. So because it can be written in this form without changing the value of the function, that means we can write this as x plus 2 and then squared. Let's try this next one. So when I look at this one, x squared minus 6x plus 9, I know immediately that I need to use this second formula. But the question is, can I write it in that form? Because if I can, then I can write the trinomial in the form a minus b squared. So first, look at the first term, it is x squared. Then look at the last term, that's 3 squared. So you can see that a would be x, and your b in the formula would be 3. So the middle term, if it is minus 2ab, it would have looked like 2 times x times 3. And when you multiply, 2 times negative 2 times 3 gives you negative 6, and then negative 6 times x is negative 6x. So we just rewrote x squared minus 6x plus 9 in the form a squared minus 2ab plus b squared. So that means we can write it in the form a minus 3 and then squared, which is this side of the formula here. Typically, these are both in the vertex form, but it's not always that we end up with a perfect square form like that. Let's look at this example. X squared minus 6x plus 12. If we were to do the same thing, the first term is x squared. We're good there. But the last term, 12, is not a perfect square, so you can't immediately write it in the a squared plus 2ab plus b squared form. So the question is, how do we write it in this form, and then maybe with an extra constant at the end? So first, we would need to write the function in this form, x squared minus 6x plus 9. Now, because we are adding 9, you would need to subtract 9 and then bring down that plus 12. By adding 9 and subtracting 9, we're not changing the value of that function. And as you can see, we're still left with x squared minus 6x plus 12. But now this will become x minus 3 squared. And combining these two terms, that will give you plus 3. So now we have a vertex form of the function. We're going to try another one. What if now we have x squared minus 8x plus 5? First, we need to write it in a perfect square trinomial form, like what we did with x squared minus 6x plus 9. There is a quick way for you to figure out that constant that you need to add and subtract at the same time here. So to do that, you are going to take the middle coefficient, which is negative 8, divide by 2, and then square it. So basically, we are doing b over 2 and then squared. Now that will give us negative 8 over 2, which is negative 4, and then squared, which gives you 16. So this will become x squared minus 8x plus 16, and then we got to subtract 16 at the end. We'll bring 5 down. So this right here, that's an x squared, that's a 4 squared, and the middle term is minus 2 times ab, and that multiply exactly to negative 8x, and then bring down the minus 16 plus 5. These three terms will form x minus 4 squared, and then combine these two, we get minus 11. Now this will only work if a is 1. If a wasn't 1, then we'll need to add an extra step. So let's see how it's done. So example 3, given f of x is equal to 3x squared plus 12x plus 5, write the function in vertex form by completing the square. So our goal is to convert this to the form a times x minus h squared plus k. 3 steps. Step 1, make sure the function is in standard form, and it is. Then factor a out of the first two terms. The first two terms are ax squared plus bx. And only do that if a is different from 1. So now we are going to factor a out of the first two terms. So I'm going to rewrite the function 3x squared plus 12x plus 5. A is 3, so we want to factor 3 out of those two terms. So we have 3, and then x squared plus, that will give you 4x, and then plus 5. Notice that we are not factoring out the greatest common factor. We are only factoring out the coefficient a. Step 2, complete the square within the parentheses by adding and subtracting b over 2 squared within the parentheses. So let's first rewrite the function. And within the parentheses, I need to figure out what I need to add and minus at the same time. So I'm not changing the value of that expression. So we're going to do x squared plus 4x. And to figure out the constant, we're going to do b over 2 squared. Now b within the parentheses here is 4. So 4 over 2 squared. That will give you 2 squared, which is 4. So we want to write plus 4 and minus 4 in parentheses, and then just bring down the plus 5 on the outside. Now, step 3, we are going to properly move the minus b over 2 squared, which is this constant here, outside of the parentheses by using distribution. So we are going to distribute with the 3 so we can move it outside of the parentheses. So we have 3 x squared plus 4x plus 4. We'll keep the plus 4 in parentheses. And then the minus 4, when you move it outside, it will become minus 12, since 3 times negative 4 is negative 12. And then bring down the plus 5. Now this will become x plus 2 and then squared. And then we just combine these two terms. We have minus 7. And there we have the vertex form of the quadratic function.